Hello guys, this is the recording for Android Lecture 1. We were unable to record it actually during the actual lecture, so I'm sitting on a computer and re-recording it for you guys. So for starters, I'll describe a little bit about the club before we go into actual Android, and then I'll introduce myself, and then we'll actually go into Android a little bit in an abstract perspective. We will be talking about what consists of what main components make an app, and then we'll actually be coding. So, for starters, we are an actually project-oriented club, so we're aimed at developing, not actually teaching. But because we don't have developers right now, we have decided to make an introductory course to teach you guys about the respective platforms, just to jumpstart you guys and be able to join our development team. To join any of the development team, there's the Android Bootcamp, as you can see on the slides. Or the respective bootcamp for any other platform. You have to complete this bootcamp assignment to be able to join the team as a developer. To become a member of the club and attend the lectures and just come to our events, you don't need to at all. You just need to let us know and we'll add you to the members list. So, so the goal of the introductory course is to teach you enough to continue on your own. Just enough to learn where to find the resources, all of that kind of stuff. Right now we have two main projects, which is the UFT Utilities app. We're going to try to make it official. We are talking to UFT and we'll get back to you on that. Basically, the idea is to make our campus a smart campus. So our app will be integrated with UFT's databases and we'll be able to tell you if your lecture location has changed or if the book became available at the bookstore, what's the price, where you can find it, all of that kind of stuff, and also be able to help you find your final exams. So I'm not sure if many of you have experienced this yet, but at the end of the year or at the end of the term, there's a huge list that comes out with all of the exams that are coming out for engineering. And I'm not sure if it's the same for other departments. But what usually you have to do is then go to that list, start Command F or Control F, looking for all your courses and writing them down on a paper. So that's one of the things that we want to actually include in the app, where you would simply be able to look it up, and you'll find you type in your courses or maybe just your user ID, and it'll give you your schedule. So that's one thing we want to include. So that's the basic idea of the first app. The second app will be CUTC. It is the Canadian Undergraduate Technology Conference. We will be building their official app for Android and iOS. We don't have much details on that right now, but basically CUTC is the largest and longest student-run conference in Canada. The plans are to have about 1,000 people attending it for this summer. So a little bit more about the intro course. It's going to be 4 to 5 lectures, just like your other lecture, 50 minutes each. However, those 10 minutes before will be a review of the previous one, so it's an optional review. You don't have to be there. I won't be teaching anything new there, but for the other 50 minutes, we will be going through the rest of the material. It'll start at 10 past, just like every other day, just like any other lecture. So as I said, the goal is to learn and continue on your own. Specifically Android basics and the abstract ideas as well as the actual programming perspective. How to find and use the online resources. There's actually a lot of them because it's Google. Where do you look for stuff? It's always on Google. And how to use the actual tools, and maybe if we have some in time, test-driven development with JUnit and maybe RoboElectric. Probably not. We'll see. So, a little bit about Android. It wasn't actually a Google product at the beginning. It was acquired by Google in 2005. It used to be Android Inc. It was funded by Google at the time, and then Google bought it out in 2005. It's completely open source, which is actually really, really cool. So, there were many times where I'd encounter some weird behavior, maybe a bug, maybe not, just something I don't understand in the code. And while using some of the Android system calls or system code, not something I implemented myself. And what I would do is simply go to a website called grepcode or just look it up on Google, and I would look at the code that they had actually built so I can see the statements and where it breaks or where it's being undefined. And there were actually a couple of times where we would find a bug in the Android code and we would actually just like copy it over and fix it. instead of just filing the bug and waiting for the company, Android or Apple or whoever it is, to fix it. We would actually just go ahead and fix it for our app. And then when they fix it, we'll just remove our fix and just use theirs. So it's actually really, really, really nice being able to see what happens behind the scenes. It gives you a much more in-depth understanding of the system and the workings and everything involved. And another point is it's easy to mod because it's open source. It's easy to mod it, easy to port it. If you look at a website called CyanogenMod, you can see all the mods that people have made. So they would take the Android operating system and add a percentage sign to the battery symbol, or make it a little bit faster here, or maybe add a color there, or add a new option to do this. You can do that because the code's all there. You can just download all of Android, change whatever you want, and recompile it, and you're done. And it's also easy to port because it runs on a Linux kernel, which is the same kernel that most of phones use, and all of Macs, Ubuntu, Linux machines, the ones on your computer, they're all Linux. Everything uses Linux. Hell, even servers use Linux. So it's easy to port it to anything that can support Linux. And it's easier to ship to market compared to iOS because there isn't any, what's the word to use here? There's no procedure to go through. There's no one checking your code, which may be a bad thing, but you submit it to the app, it's there instantly. You don't have to get approval from Android or from Google, while on iOS you do. And it has the largest market share, and there is a link to that on the slides. Citation. So now let's get into Android a little bit. So the basics of Android. Actually, one note here I want to make is these slides, and actually in this club in general, we assume that you know a little bit of programming. So we won't be teaching you what a function is, what a variable is, what a loop is, what an if statement is, or any of that stuff. We will assume you know how programming works in general. You just don't know how to program for Android. And so that's one assumption to keep in mind. We will be posting up resources. We will be helping you guys actually learn programming for those who don't. However, these lecture slides assume you know a little bit programming, and I'm just going to get into actual Android. So the basics of Android. There are four main components. Excuse that extra parentheses that's open. We have activities, services, content providers, and broadcast receivers. An activity is basically a screen where you interact with the user. So it's basically there just for user interaction. That's where you see text, that's the thing you touch on your phone, where you swipe things, you have a list of items on. All of that is happening in activities. And that's essentially the main purpose of an app, to be able to interact with it and have it do things for you. Now, activities are only running on the UI, which means if you leave an app, the activities are not there anymore. So how does a music player work, for example? Because it will keep playing music even in the background. So that's where services come in. Services are things that are running in the background. They are running constantly unless you unless you stop them or the system stops them. But those are the things that happen in the background. For example, on news applications, that's what pulls the server and asks if there's new news coming up, or your email, or an MP3 player that plays music even in the background after you left the app. That's all happening in services. And so content providers are basically what they say, content providers. So a news app or an email app will use a content provider to get the content, whether it is emails or articles or images or tweets or Facebook posts or any of that stuff. You would probably use content providers. Now, one thing to keep in mind is a content provider is actually a wrapper. It's something that surrounds the actual logic to get the content. So it's not absolutely necessary to have one. You can write your app and have it working without one, even if it gets content. But it's usually useful because the Android OS will handle much of the logic involving the content, and will actually give you the state of the content at the app launch. So there are many apps that once you launch it, it will tell you, oh, you need to update, or it will tell you immediately it's refreshing, or something like that. The way it knows that is because the content provider was initialized before the app actually started launching. So it's a little bit useful. We won't really get into depth with it in this course. Broadcast receivers are broadcast receivers. So what is our broadcast? Something like your battery is low, your signal, you don't have a signal anymore. Anything that the system thinks that um, apps may be interested in. So there are apps that monitor your battery life. There are apps that actually monitor calls. Any kind of event that happens on the system that other applications may be interested in would be a broadcast. And to tell the system I'm actually interested in this and I care about the battery or I care about an email, then the broadcast receiver is what would you would define and what would handle that. Now, apps can also launch broadcasts. That's something to keep in mind. And all of these are declared in the Android manifest file. It's an XML file that the system and the Google Play Store use to gather information about your app. This is a very basic overview, and now we will go in depth into activities. For this course, we won't really be going into depth on services and broadcast receivers. We may touch upon content providers for a bit, but it will be mostly activities. So, an activity is a single focus screen that is usually used to interact with the user. And since this is a lot of the work that happens on an app is on the activity, it is essential that you actually read the developer resource. There's information about the life cycle, there's information about a lot of stuff that sometimes people spend hours debugging because they simply didn't read the documentation, and that's simply how they defined it. So it's very, very important that you actually read that. It's kind of long, but it's well worth it. So there are 4 stages or 4 things to know about creating about an activity. How do you create one? Well, there's 2 things you have to do for an activity. Since activities are made to be an abstraction, as in they should work on their own. You shouldn't, or in many cases at least, you shouldn't need that many other activities for this one to function. So I'll give you a simple example. If you are in the Gmail app or just any mail app and you hit the compose button, you enter some kind of activity that handles the composition of an email. That activity does not really depend on the inbox activity being there somewhere else or the mail one. The easiest way to see this is if you are browsing the web or browsing some other app and you hit some contact or an email button, and it will immediately launch the email application's compose activity. In that case, none of the other activities are there. So the beauty of activity is it's a single modulated it's an abstracted object on its own that does everything it needs to do only within that activity. So there's 2 stages. One is you create it and you actually create the activity and you define its interface, the UI, and then you actually have to tell the system what this activity does if it's supposed to handle emails or something else from the outside. So or if it's the activity that's supposed to be launched when your app is launched, you have to tell the system, by the way, when someone opens my app, this is the activity I want you to launch, because there could be many, many activities, and the Android system isn't just going to guess. So you have to specify which one happens at app startup. So you can start an activity in 2 ways. One is the way I just described, which is the system automatically starts it because of either app launch or because another application asked for it to be launched, or you can do it you can do it that way, or you could do it programmatically. In one of your activities, you could say, I want to start a new activity whenever he presses this button. And activities can be started for a specific result. You can have an activity launch just to gather information and send it back to the activity that launched it. For example, if you are in your Twitter app and you hit settings and you change the user, you might want to send that information back straight to the activity. We'll go through this later with more examples. And then you can, there's 2 ways of shutting down an activity. One is you simply back out of it, or there's nothing happening on the activity anymore, and then the system will finish it. Or you can manually say, I want activity X to finish when this happens. So maybe you're downloading an app or downloading a file or something, and the moment the file download finishes, the service that was downloading the file would say the activity finish. You're gone now. And one really important thing is managing the activity's life cycle. So an activity has four main stages for its life cycle. It is created. Actually, I'm just going to look at the slides. Nope, that's not it. It is created, resumed, paused, and destroyed. I will go into the web browser and give you guys examples. Activity. Okay, so this is the documentation for an activity, and here is the life cycle. So whenever an activity is launched, the first thing that happens is it gets created. And then this create method, this create callback, or this creating stage only happens once in the activity's life cycle, while the other ones could happen multiple times. Allow me to explain. So after it's created, it's started, it is then resumed, and then it'll wait until something else happens. This is when the actual interaction happens. Like, for example, in the screen box is when you would be typing down your email in the compose activity. So the activity itself isn't going through any major changes. It's just you're typing into it or using it. And then when the activity is done, it will be paused, stopped, and then destroyed. These are exact complements of the methods above. So destroy will only happen once, just like create will only happen once. Start and resume and pause and stop could happen multiple times. An example of when an activity would be paused is you're browsing through an app and then your phone gives you that pop-up that says your battery is low. Well, the activity in the back is now paused. It's not destroyed, it's not really stopped, it's still there. You can still see it, it's just paused. So that is a callback that the system tells your activity, calls to your activity telling it you've been paused because something else has the main focus right now. That's a pause. So that's an example of a pause. And when you come back, it will be resumed. When you dismiss that dialog and go back to the activity, it will go back to on resume and then continue into the green box as always. Keep in mind that at the very, very launch of the activity, all three happen in sequence. And then, an example of stopping and starting would be if you navigate to another activity. So you are going through your mail application, you're at the inbox or something, and you hit the compose button, it takes you to that new screen where it composes an email. Well, the activity in the background hasn't been destroyed because when you leave compose, you can go back to it. It's still there. However, it's not visible, you can't interact with it, you don't know, it's not being drawn on the screen, it's nothing. So it's stopped in that case, which means you will get both callbacks, pause and stop. You can go go through this in more detail, but that's just a basic idea. Here's a more detailed explanation. This is the activity class that I was talking about, and it's a must read. You don't need to read all the information in here, although I would highly recommend you do, because most, if not all of it, is very important, and chances are you will encounter issues that would be explained here, and it would take an hour to debug them if you didn't actually go through them here. And restart would happen, for example, if you rotate, or if you navigate to the activity from another location. If you were able we'll go through the code, for example. I can't think of an example off the top of my head. So back to slides. That's the basic idea of an activity. Now, now let's actually get a little bit more exciting into actually how things appear on screen and how they work. Everything that can be drawn on screen is a view. Everything. Whether it's a text box, whether it's a button, whether it's a video, anything that gets drawn on the screen is a view. A view is a basic class that just can be drawn. Now, there's two different types of views. There's a normal view, just a view, which is a text view, an image view, a button, or something that actually gets drawn. You can have a video, text, button, as I said, anything like that. That's actually a view. And then you have a view group, which is a collection of views, so it's more or less the layout. Now keep in mind that a view group is also a view, but a view group, I can give you a couple of examples of view group. For example, when you have a list of items. So let's say you're looking at the Twitter app and you see a list of tweets. That view, the list itself, not every single tweet, that view in general, has inside of it many tweets. So that view, which is called actually a list view, is, for example, a view group. Or the screen in general, the top level view of the screen, has many children, as we say, inside of it. It has the text boxes, it has images views, it has a list view inside. So a view group is simply a view that has many views inside of it. Now keep in mind that the view group itself is not meant to be drawn. It doesn't have that much drawing to do. Its children are what get drawn. So for example, the Twitter app, the list itself you don't see. You see the items in the list. The only item you see from the list is the scroll bar, if that makes any sense. And they essentially form a hierarchy. There's no limitation on how many views you can have inside a view group and how many view groups are inside of view groups. It's completely dynamic, and I can actually give you an example. View group. Maybe not here. Yeah. So here's an example hierarchy. So your very top level view is that one. And then inside of it you have two views. So maybe this could be like the title at the very top of the page, and this is a button to say go back. And then you have here a view group which has multiple views inside of it. Keep in mind that this is also a view and that one is also a view. So this is a quick example of what it would look like. There are many types of view groups. There's relative, there's linear, there's frame, there's all of these kinds of what we call layouts. Relative layout, linear layout, frame layout. A relative layout is where you would lay things inside relative to each other. So for example, you would say, I want my image to be at the top left and my text to be right below it, while the button is at the bottom right under this. So that you would need a relative view group to use. You would need to use a relative view group to be able to obtain that. A linear one is simply a linear one in terms of it just lays everything beside each other. So when you have 6 views inside a linear layout, it will put them right beside each other. There's two types of linear layouts, vertical and horizontal. A vertical linear layout will have things just go on top of each other. So view number 1 would be the very one at the top, and then the next one's under it, and the next one's under it, and under it, and under it, and under it. An example for that would be if you were if you were writing tabs. If you've seen many apps that use tabs, you would have like a checkout tab, an info tab, a my account tab. That tab, that layout that has the tabs inside, has just a bunch of views right beside each other. That might, for example, might be a linear layout. A frame layout is whenever you need. I'll give you an example at the end of the lecture, but a frame layout is meant to only have one view inside of it, which is basically you have a view, but you need to put it in something. You can't put it as itself. You have to put it in something. I'll give you an example. That's a frame layout. Oh, and one little thing, which is every activity is usually only connected to one view at the very top level. So an activity has its one view that's associated with it, and that view may be a view group with a bunch of stuff inside, maybe just a view, the text view, could be anything. But an activity is usually associated with only one content, with one view which has the content inside of it. We call it a content view. All of this information, and the other component that's really important for an app, was the Android manifest. This is where all of that information is declared. What activities I have, what permissions my app needs. Does my app need to access the internet? Does it need to be able to make calls? All of that stuff that you see in the Play Store when you're downloading an app, this app has these following permissions. All of these are declared in the manifest, and they're enforced by the system. You can't use the internet if you don't declare it, and so anything you see there is actually accurate. So then what does the manifest include? It includes the application permissions, and there's two types of permissions. Used ones, as I just explained, are like internet, access to the battery, access to the contacts, or contacts or any kind of any kind of permission that the system provides that you need to use, you can declare. Or there's permissions that you can actually create yourself. Um, so, for example, let's say my app is Instagram, and I want to let other people use my features. Then I would create a permission called Instagram, for example, and other applications can say I want to use this permission. So you can create your own permissions as well as use ones that are defined by the Android operating system. The other thing you have to declare in the manifest is the SDK version, which is the Android version. I'm sure many of you are aware there's many different versions of Android. You have Donut, Eclair, Froyo, which actually stands for frozen yogurt, Gingerbread, Jelly Bean, and Ice Cream Sandwich, and I think there's even more, but I don't remember them. There's Donut, I think. So all of these uh, operating system versions for Android have a number. It's called the SDK number. Jelly Bean, for example, started at 16, actually maybe 15. Ice Cream Sandwich started at 14, I believe. Honeycomb was at 12. Froyo is 2.2, which is 8 or 7. All of these have numbers. You have to declare in your application, my minimum supported SDK is this, and my target one is that. This is so that people that aren't supported won't be able to download it off the Play Store. There's the application object, which describes your actual application. Within it is all the activities and all the broadcast receivers and services and content providers. All of these go under the application object tag. And I'll explain the package name actually when we're coding. So let's actually start programming. The example we're going to go through is Hello World. We're going to code Hello World in two different ways. If you saw on the view slide, there's two ways of declaring the UI or views. You can do it programmatically or you can do it with an interface. And we'll go through both examples now. A little bit of technical information about Android before we actually get into the code, because I haven't said anything yet about that. So Android, as I mentioned earlier, it runs on a Linux kernel, which means it essentially has the same command line prompt that you've seen on the engineering computing facilities, ECF computers, or any Linux operating system, including Mac. So yeah, you don't have root access. You can't use sudo. Native apps are written in Java, or you can actually write them in C and C++, although they're highly discouraged. It's completely object-oriented, so it's really simple to think about, really simple to use, and runs on a Dalvik virtual machine, which is essentially the same as Java and Java Virtual Machine, but is a little bit different. For all intents and purposes, that doesn't matter to you. You just write Java, you compile Java, and it just works. There's one UI thread. There's only one thread on the system that does all of the UI, whether it's drawing buttons, whether it's picking up a click, any kind of thing like that is all in one UI thread. Applications become .apk packages. That's what you actually download from the Google Play Store. It's an APK package which gets installed and then it runs. Updates are diff files, not actual full packages now. So if you downloaded a game that's a gig big, but there's an update that changed one line of code, you don't have to download the entire thing. You can download the changes that that line affected. And the only con to Android is the limited RAM. Because Android actually supports multitasking, it has a lot less RAM than iOS devices. So if you remember, iPads, iPods, and iPhones, actually not, iPads weren't even there at the time, only supported one application when they first were launched, and that was because it didn't support multitasking, and so all the RAM on that device would be allocated to the running application. So it gave you a lot. The old versions of iPod actually supported up to like 64 megabytes for RAM. Those are the old one. That's iPod Touch second generation or first generation. I think it gave you 64 or 32 megabytes. The most recent version of Android actually gives you 48. So the most recent version has less RAM than the oldest version for iOS. Now, sure, you could say that sucks, but the advantage of it is it actually supports multitasking, which means if your application, if you don't actually shut down your application, you're guaranteed it's going to keep running unless an emergency happens. While on iOS, even though now it supports multitasking, it still doesn't really, because if uh, if an application is running right now, it has rights to as much RAM as it needs, which may actually kick other applications off of memory and shut them down. So it doesn't really let other applications run for as long as they want. It lets them run as long as no one else, as long as it needs them. As long as, sorry, once it no longer needs the apps, it will shut them down. So it's not really the same. It gives you more power on Android, but less RAM. All right, so let's do Hello World. And I actually just realized I did not introduce myself. I'm Muhannad Abwa. I am the Android director, and I've been programming for over 7 years. Been teaching for as long as I can remember, and I'm currently working at Extreme Labs as a mobile software engineer or an agile software engineer. I've worked on Reuters' official app. I'm currently working on NBA, which has millions of users. And I think that's pretty much all I need to really say from myself. I'm an undergraduate student. I'm still a student. I'm going through my fourth year, but I'm currently doing PY. I'm a fourth year student, but currently doing PY at Extreme Labs. And I think that's all that's really important. So for this demo, I'll be assuming that you guys had set up Eclipse. I will be linking to the Android developers website, which will help you set up Eclipse and actually walk you through Hello World as well. I'm doing a little bit more than what they just did, and then on the next lectures we'll go even deeper. So I'll be assuming you have the environment set up. Let's go to Eclipse. So the first thing we need to do is to actually create a project. So let's do other, and then we have Android application project. We will call it Hello World. And this is something that actually I said I will mention later, the package name, the reverse domain notation. So basically, whenever Java was starting up, because it runs on a Java virtual machine and it's meant to run on many different devices, they were afraid that people would have their projects conflict with each other. So they had to think of a way that would make every project unique. So they took the websites or the domain name associated with every company or project or whatever it is, and they would reverse it. So, for example, in our case, our website is uftdev.ca. So the project's name would start with ca.uftdev and then dot whatever you actually want to call it. For our case, we'll just call it Hello World. This is the Android version that you want to target. This is your target one. This is the minimum supported one. We'll choose Gingerbread. API level 10 has about 53% of the market, if I'm not mistaken. So we'll support down to that. Although technically this Hello World app would work on any of them because it's so simple. But just so you can know how to set up a project. We don't want to create a custom launcher icon. We don't want to make this a library. We do want to actually create it. So we'll go forward. We don't want to automatically create an activity. I actually want to walk you through that process. So now we have an app. If I run this app, I'll see nothing because we didn't do anything. Okay, so let's go in. We'll create a new class. We'll put it in the default package, which would be ca.uftdev.helloworld. We'll call it main activity. I'm basically creating the activity that I want to launch at the start of the app. And it extends activity. Android.app activity. Alright, cool. Let's hit finish. We have our activity. Now, at which stage would we actually insert this view that we want to show to people? If you remember from the life cycle of an activity, we have on create, we have on resume, we have on pause, and we have on stop, and we have on destroy. All of this drawing stuff and destroying and all of that happens in these life cycles. almost everything that happens in an activity has to happen in one of these methods. There are a couple of other methods that are sometimes useful, but in general it'll be all of these guys or some of these guys. So in which stage would you imagine that the view would be created and displayed? Almost like I'm sure you would know it would be in onCreate. So in onCreate, let's create the text view. I will call it hello. And the constructor for text view actually needs an activity. Fix the imports, and we have a text view now. So now that's a text view that says nothing inside. So we will set the text inside to say hello world. Okay, great, cool. Now I've created an activity, I've created a text view, but I've never put that text view in the activity. I didn't actually assign it to be drawn. I didn't set it to any kind of view. I didn't associate it with the activity. If you remember earlier, I said every activity is usually associated with one view at the very top level. Well, since we only have one view in this case, we'll set that one to be it. So there's a method in an activity called setContentView. And then you pass it in a view. Now, okay, cool. So this works. By the way, this is the same as saying this. You don't need to say it. You can choose not to. Alright, so I've created an activity, I've created a text view, assigned the text to say hello world, and I've actually set it to be the main text view for that activity. The only thing missing right now is I never told the Android system to actually start this activity when you launch the app. I never defined that. So I created an activity, but the system doesn't even know that this activity has been created. I need to actually tell someone to start this activity, and that would happen in the manifest. So this is the Android manifest. We usually use the XML form because it's easier to see, understand. I'm just going to format it. That was just an auto format. I didn't change anything. There's the old, there's the new. So this is the minimum SDK version. If you remember, this was gingerbread. This was ice cream sandwich, I believe, or jelly bean. Not sure. If you're at level 15, this is the version code. This is what you usually see whenever you download an app and it says build 2600 and whatever. That's the version code. And then the version name is, well, it's like, I don't know, Hello World 3.0 or something. That would be it. That's the package name. That's for resources. And then this is the application object. Or application element, if you want to call it that. This is the icon that's used on the main menu page. So whenever you go to the home screen or the menu screen, this is the icon you use. I didn't change it, so it's probably the default one. This is a string resource. If you go to actually resources folder, you can go to values. You'll find strings and styles. If you go to the strings file and look at an XML form, it has only one string inside. The string's name is app name, and the string is actually saying hello world, and that's what's used right there. And then there's the default style that Android uses. We don't really care for that right now. So this is just saying what the app's label is, and it's the application's label is that string name, which is right over here. Okay, so now let's add our activity. Our activity's name is CA. You have to actually include the package name and everything up to there. CA.hello world dot what was it called? Main activity. Alright, so I've created my activity, I've declared it. Now the system knows that this activity exists. Now the problem is I could have many activities. So I need to tell the Android system that this is the activity that you should launch when the application is, like when the application icon is pressed. That this is the main launcher activity. So what I'm about to type right now, it's not really important to understand it right now. It's a little bit of a complicated concept that we'll get into later. But basically, whenever you launch an activity, it's the application, the system gives you a sort of intent, and then you have to filter it to say I'm interested in that specific intent. And this is basically me just defining that and then telling the system what to do when you see that intent. So category, we need to define a category and an action. These two lines, just as I said, for now, just copy paste them, write them the same, and they will simply work. So the category's name will be main, I believe, nope, launcher, and then the action's name will be main. So let's quickly walk through. I created an activity. It extends the class, the abstract class activity. I believe it's, oh, yeah. But anyway, it extends activity. It's called main activity. It's defined in the package ca.uftdev.hello world, which is actually the default. Um, I overrode the onCreate method, so I can actually do more things than the default one would do, because the default one wouldn't actually do anything in terms of views. So I overrode onCreate. I actually still called the activity's default onCreate method, so anything that it used to do, I still want it to do. I just want to add more to it. So after activities onCreate finished, I created my own text view. I set the text inside that text view to be hello world, and then I set it to be the main content view for the activity. I didn't do anything in the other lifecycle methods, so those, as if you remember, I erased them. They all have their default behavior. I didn't touch those. And then I created the activity, but I never told the system to start it. So now we go to the manifest, and I define the activity here, and told it to start it. This is basically saying it's the main and launch it. So let's run it. I'm gonna use a virtual machine so you guys can actually see what's happening. So the nice thing about Android is the Android development tools will connect it to the computer. So if you had your device connected, or if you had just one emulator running, the moment you run, it'll just choose that device because there's nothing else. If there were multiple devices, it'll ask you which device do you want to run the application on. But it's literally just as simple as hitting run and you're done. That's pretty much it. It works. Let's wait for the emulator to continue running. It usually doesn't take this long. There we go. So now the emulator is running. I'm gonna hit run. I'm gonna run my Hello World project as an Android application. I actually have my phone connected, so I'm gonna choose. So that's why it prompted me. If there was no other device, I would have just run it. But because my phone's connected, it asked me. I'm gonna run it on the emulator, and there we go. There you see. It's an application called Hello World. This is the only one activity I have, and this is what it says. If I back out of it, it leaves the app just like any other app. If you look here, you can see the app. You can see its info. It's installed like any other app. You can force stop it. You can uninstall. You can do anything you want. You don't need to uninstall from one launch to another. I'm just showing you guys. So the next thing I want to do is explain a little bit about those view groups I mentioned earlier. So let's actually rerun the app so I can show you guys. But what happens if I want to take this and I want to put it in the middle? So let's look at the actually no, sorry, before that I showed you now how to build this app and this hello world programmatically. But when you're building a more complex design, you don't want to do that in code, because then you have to position the items, make them go relative to each other, size them, and all of that stuff. It's going to be annoying to do it programmatically. So it'll be really useful to see that graphic interface I mentioned earlier. So let's get rid of the text view. No more text view. Deleted those lines. And now I need to fill this in with something. I still don't have that thing, so we'll get back to this later. Of course, it's complaining because I don't have a content view. So now we'll go to resources. We'll create a new XML, Android, yeah, XML, there was that. XML layout file. I'll actually do it as a file so I can show you what happens inside. Alright, so what we want is to do a text view. Where is it? There. Basically, we're going to do the same thing we just did, but with the graphical layout as opposed to programmatic. So I will call the file activity_main. You can call the file anything you want. I just chose activity_main. So now I have a text view in an XML file. What do these mean? So every view has parameters for itself and parameters relative to its parent. Now, if you remember the hierarchy, I'll actually pull it up so I can show you guys. UI Android. Let's go to no, overview. I lost it. Alright, so what we just created is actually a view, not a view group. But every view could have a parent, and in fact, even the top level view right here has a parent, which is something that the Android system implements that has your activity inside. It's not important, how exactly that works. You just know that there is a parent. So what happens is when I'm inside my parent, when a view is within its view group, it needs to tell it what to do with it. How much space is it going to take? Because many times the parent will just be as big as all of the children inside. So it would need to know how big the children are. So basically here I'm saying I want to match the size of my parent. In this case, we don't really want the text view, we don't really want the text view to span the entire activity, right? It's just that big. So I'm going to change that to wrap content for both height and width, and that will make the text view exactly as big as the text inside. And you can leave it this way, but since it's a view that cannot take children, it's recommended you just do this. You end it right there. You don't have it expanded and allow for elements to be in with it. So now I have a text view that wraps its content, but there is no content. So if I go to the graphical layout right now, I'll see nothing. By the way, the graphical layout will give you a live, like instant feedback on what the activity will look like when you run it, but it's not actually running. That app this is the old one. Right now, it won't even compile because of that error. However, it's still showing me what my activity will look like. So what do I need to do this text view right now? I just need to add the text to it. So I will say Android text equals, usually there's no space, hello world. And now chances are Android will complain because of externalizing. I'll explain that in a second. Let's go to graphical layout, and now I can see it. Now, so I've created, actually I'll explain the string externalizing now. It's telling me to extract string. Explain issue. Hard-coded text attribute directly in error is bad for several reasons. When creating configuration variations, you have to repeat the actual text. The application can be translated to other languages. So what happens is you see this file right there, that strings file and values. I can create another values folder called values FR, French, or Spanish, or so many other languages. And that way, if I externalize all of these strings, if I actually put it into our string file, resources string file, then all I need to do to translate the entire app from one language to another is just translate the strings file. And then Android on its own will choose the appropriate strings from the appropriate files depending on the language of the phone. So if I have all of my strings externalized to the strings file, and I have another version of it that's in the French folder, and the phone is setting to French, it will immediately just choose all of the French strings. If it couldn't find one in the French string, it'll pick the default one. So that's the idea behind this error that pops up. And you should almost never hard code a string unless you're sure it's going to stay there for all of them. For now, we're just building Hello World app. It's not really important. We're not going to be translating to anything, so I'm just going to leave this here for now. So now I've created this XML that describes my layout, and it's telling me this is probably what it'll look like. In most cases, this is very accurate, but sometimes it'll be a little bit different than what you see on the phone, because many times there's when the program is running, there's dynamic data that comes in, such as the images or the tweets. The actual program running. So if this was the Twitter app, you wouldn't actually see any tweets here because there's no data. When you run it, you'll see it. So it's always good to keep in mind that this isn't actually the program running. So now we need to go to this activity and actually tell it to use its main content from this XML. So how do I tell it that? Well, it's in this resources file, right? This is a resource. It's not code. It's not compiled. I can't reference it from here just saying activity_main. It's not an object. It's a resource file. Now, the Android development tools, once you create an XML or any kind of resource, will immediately create an object called R. And in R, there are integer numbers that that are used to reference all of those resources, whether they're strings, whether they're styles, whether they're images, any kind of resources. In our case, it's a layout file, it's an XML file. So now I will need to use R to get the layout file out of it. When it does this, if it doesn't actually, if you can't see r.layout, just clean. Sometimes Eclipse acts kind of retarded. Just let it give it a second to generate the R file, and there we go. r.layout.activity main. We don't have any other one. The other choices were the class object. For those who have done Java, we don't really need this right now. So there we go. Now, and we no longer need that import. So now, and on create of this main activity, I called super to keep the old functionality in, and then I set the content view to be this XML. So what happens is now when the system runs it, it'll get that resource number, connect it to the actual XML, and generate the view from that XML. Let's run the app. It should look exactly the same. Let's choose the emulator, close the app, and rerun it. We see the same thing. Cool. And just to actually show you that this is different, if I put a 1 there and rerun, you see the 1 there. It's not the same as the one in the code because that one just said hello world. Alright, so let's run it again and look at it. So now we have this. Now, the other thing I want to explain, since I have a little bit more time, is view groups. If you remember in the hierarchy, I said you could have views inside other views. Right now, all we have is just one view. So what are view groups useful for? I'll actually answer this in a question format. Let's say, right here, I want to take this view and put it right here in the center, as I mentioned earlier. Let me tell you what you can do for width and height. What you can do here is you can specify the width and height in a more absolute way. Let's say you want it to be this wide, like some kind of number wide. So because Android is very, very, very portable and it has many, many, many different devices with many different screen resolutions and densities and sizes and everything, it's very, very, very discouraged that you use pixels. You can say a view is 20 pixels wide. However, chances are Android will tell me don't do that. Explain issue. Yeah, it doesn't like pixels, it tells you to use DP instead. I'll explain what DP is. So DP is a way of telling you a little bit more realistically the size of something. So it'll be closer to like inches. I want it to be this big, approximately that big on generally in any screen. What it actually stands for is DIP, not DP. DIP, which is density independent pixels. So it's basically a measure of width that is density independent. So a screen will look approximately just as big on any screen, regardless if it was high density, low density, any kind of that formation. If you see these folders, these are all for the different kinds of densities. If you're trying to have a different layout for low density phones, you'd put it here. For high density phones there, medium density phones there, extra high density phones right there. This is, for example, the Galaxy S3 and then a Galaxy Nexus 7 and the HTC One X or XHD DPI. So you could use DIP or DP, but they're both the same. Most people use DP. There's no specific reason for that. So that's what you would use for heights and width. The problem is this specifies the height and the width of the object, not really its position on the screen. So let's leave this as wrap content. It won't help us. You can do the same for height, of course. So let's see, what else do we have? These are all the things I have access to. Now, we don't want to actually go through those and explain them. We'll go to something called padding. Right there, padding. There's left, top, right, bottom. Start and end are not almost never used, so let's skip those for now. You can read their descriptions when you're programming. Padding is basically how much space goes around the cell. Now, the problem is, let's say I wanted to use padding to center it. I would need to know how much padding I need at the top, left, right, and down. that's something you would need to calculate because it's the height of the entire screen divided by 2 minus whatever height this thing takes. So it would be something you would need to calculate, and you can't really do it here. So the way you would actually do it is you would need it to be within the activity and just tell it to be centered. But how do I do that? So I need some kind of parent. I need it to be within some kind of container. And then I can tell that container, yo, place me in the middle. So let's actually do that. I will wrap in container. What I hate is command 1 for those interested. I will wrap it in a container. I will wrap it in a frame layout. I'll explain a little bit of what these layouts are right now. A relative layout is something you would use to position items relative to each other. So you want to say this is to the right, like I want the image to be to the left of the text, and underneath the text there should be the date, and on top of it should be the guy's name. While on that right or on the top right edge of the corner, the parent, I want this. That's what you would use a relative layout for. A linear layout is when you want to position items just like in sequence right after each other. For example, this box, I would imagine. Actually, no, that might not be a very good example. Actually, yeah, this box would be be a relative layout. You'd have this on the top, this right underneath that one, these three guys beside each other aligned to the bottom of the parent, this guy on the left below this. That's what would a relative layout look like. For example, a linear layout is when you have items just after each other. This would be for example, that right there, this line would be a horizontal linear layout, and that would be just item 1, item 2, item 3, just lay them out right beside each other. What else is there that's relevant? A vertical linear layout would be almost the same, just vertically. So this might be a vertical linear layout because you just have a whole bunch of items under each other. A grid layout is a grid. So when you're looking at the image, at the photo application on your phone, that would probably be a grid layout because you have a bunch of photos in a grid form. And there's more, you can investigate them. But basically what we need is called a frame layout, which is basically, it's just a frame. It doesn't really do any laying out logic. It doesn't separate items. It doesn't go like, oh, this one goes here, that one goes there. It's literally just a frame. It's just there to be there. So we need just a frame layout because I don't have multiple items that I want to position relative to each other. We don't really need the ID. I will be neglecting that for now. Delete it. No ID. Now the frame layout, which is the parent of the text view is inside my frame layout, I need that to span the entire activity. So I can center the text view within it. So this guy needs to be a match parent. So now my frame layout spans the entire activity. And inside my frame layout is my text view. Keep in mind, of course, that the frame layout is a view group. So this would be the frame layout, and this would be the text view. And none of these would exist anyway. In this case, we just have a view group with another view. Now, I can say, just as I told my parent here, layout usually means I'm telling my parent something. Text means it's for the view itself. So this attribute is for the text view itself. This attribute is for the parent to understand. So basically here I'm telling my parent, I'm wrapping my content, height, I'm wrapping my content. I need to tell my parent that my gravity is going to be center. There's many options. We want center horizontal and vertical, which is just center. So now I have my frame layout spanning the entire parent. I have my text view, which only wraps its content, is only as big as whatever's inside of it. And then I'm telling my parent, place me in your center. This guy spans the entire screen. The center of the screen, vertically and horizontally, is the center of that screen. And this is what ends up happening. Hello world is right in the middle. And if we run this, we can see it. On the emulator, nope. And there we go. And of course, this app, as I said, is still on the phone. It's actually just a normal application that you can install on any Android phone. If you plug in your phone and go into settings, there's developer options at the very bottom, I believe. Some phones will be inside applications, then developer options. You can go there and then you can enable debug mode. Actually, I can probably show you right here. So let's go to settings, scroll to the bottom, developer options, use debugging. On this is an emulator, so it's default enabled. You can always do that, but you would just need to enable this. Once you enable this and plug in your phone, you can hit play and it'll install the app right on your phone. And that's pretty much it for lecture 1. So I threw a lot of information at you guys in this lecture, so I want to actually show you my summary. I brought up a lot of information in this lecture. What's really important to remember is just what an activity is, which is a screen meant for interacting with the user. So my example that I always gave is if I go to, can I show? If I go to the email app, this is an activity, for example. I need something better. Nope. People? Yeah, sure. This is an activity. If I hit this, it takes me to a new activity. I go back, uh, go back, back to my old activity, and I go back. The activities stack upon each other, as I said, in a stack fashion. So this is one activity. This one goes on top of that one. That's what the animation shows you, tries to show you. And nope, no more activities. Can I do any more activities? Not really. But anyway, so when I leave this activity, I go back to the one right below it. When I leave this one, there isn't anyone right below it, so the application is closed. Of course, it's still in here in the recent applications, but the application is closed. Even these are activities. This is an activity, this is an activity, but of course, those are a little bit special because they're part of the operating system itself. That one, too, is an activity. Oh, there's my application. Ta-da! Anyway, that's pretty much it for today. What you really need to remember is what an activity is, how to use it with the manifest, what a view is, and how to actually implement Hello World. All of these are actually links in the lectures. For some reason, Preview isn't showing me them. But basically, that's all you really need to remember. What an activity is: a screen for interacting with the user or displaying information, or it's just a screen that the user sees and can interact with. The manifest is where everything is declared, from permissions that that the Play Store is interested in, to what activities are declared, what broadcast receivers, what services, what content providers. All of that kind of information is in the Android manifest. It's read by both the system and the Google Play Store. And you need to remember what a view is, which is anything that can be drawn. View groups are also views, but keep in mind that a view group is not drawn itself. We couldn't see the frame layout itself. What we saw was the child of the frame layout, which was a text view. And then just remember what the steps we walked through for Hello World. For almost all of the lectures from now on, we will not be using programmatical definition of UI. We will be using the XML layouts because that's the easiest and most convenient thing to do. Um, and that's it. Thank you guys.